Good morning, everyone. Yeah, very good morning. Shall we begin the session? Today's topic is part number 2, database design. We are finished with the part number 1, that is analysis and the investigation. Next part is part number 2, that is database design. So basically, there are various approaches in the database development. First part is analysis that we have finished. Next is the designing that includes the various diagrams, pictures. So database systems are designed to manage the large bodies of the information that brings information not in the isolation but also works with the various terms, various conditions. The first two approaches is designed with the focus with the design of the database schema. That includes one of the main diagram, ER diagram or ER model, entity relationship model. All right. So wait for 5 minutes more. Okay. So let's start now. So database design mainly focus on the ER models, that is the entity relationship model that we have described in chapter number 2, that is high level data model. And instead of representing all the data in the table, it is better to use the basic objects like entities, relationship among these objects, and it is often used as the first step in the database design or database schema design. Then relational database design, that is the design of the relational schema, was covered informally in the various earlier chapter. That is the principle is based, or the main principle is to, or the main motto is to design the good database design from the bad one. And these are formalized by means of several normal forms that offer the different trade-off between the possibility of inconsistencies and the efficiency of the certain queries. Then the design of a complete database application environment that meets the needs of the enterprise, being models, inquiries, requires the attention to a broad set of the issues, and many of which are covered in the next chapter, that is chapter number 9. And this also shows that how the large applications are architected using the multiple layers of the abstraction, that is the physical level, conceptual level, and finally the chapter provides a detailed discussion of the security at the end. That is how the security will be enabled, what is the CIA, that is the confidentiality, integrity, and the availability. Let's start with the chapter number 7, that is a database design and the ER model. So up to this point in the text, we have assumed a database schema and studied how the queries are updated or updates are expressed. Now we design database schema in the first place. So we focus on the ER model that provides a means of identifying the entities. Yeah, entity can be any real-time entity and any live object or any real-time that is to be representing in the database by using the oval sign, and how the entities are related with each other, how or what are the various attributes of entity, and ultimately the design or database design will be expressed in terms of the relational database design and an associated set of the constraints. Now next chapter, or in this chapter, we are showing about the ER design that can be transformed into a set of relation schemas and how some of the constraints can be captured in that design only. Then in detail whether a set of the relation schema is good or bad, database design, and study the process of creating the good design that is either using or that is also done using a broad set of the constraints. Next is the overview of the design process. So the task of creating a database application is a very complex one involving the design of the database schema, design of the program that accesses and updates the data, and the design of the security schemas to control access to data. And whatever the needs of the users, that also plays a very crucial role in the design process, because the main motto is to satisfy the customers or the users. The main focus is on the design of the database schemas, although we briefly outline some of the design tasks also. But the main main design of this complete database application environment that meets the need that being modeled requires attention to a broad set of the categories, a broad set of the issues. And this additional aspect of the expected use of the database influence a variety of the design choices at the physical, logical, and the view levels. The next is the design phase. So for small application, it may be feasible for a database designer who understands the application requirement to decide directly on the relations to be created, attributes, and the constraints on the relation. However, we are using a direct design process that is very difficult for the real world applications. And the high-level data model also serves the database designers by providing a conceptual framework. Conceptual framework means architect, or we can say the structure base in which to specify in a systematic fashion the data requirements of the database users and the database structure that fulfills these requirements. And the initial phase of the database design is to characterize fully the data needs of the prospective database users. And the database designer needs to interact extensively with the domain experts and the users to carry out the required task. And the outcome of this phase is the specification of a user requirements. And while there are techniques for diagrammatically representing the user requirement, so we are providing the textual description of the user's requirements. In the next phase, next term, the designer choose a data model. So first, we are gathering the needs of our respective database users. Then we choose a data model by applying the concept of the chosen data model that translates the requirements into a conceptual schema of the database. So while there are the techniques for diagrammatically representing, there is the techniques for the data model also that translate these requirement conceptual schema of the database. And the schema developed at this conceptual design phase provides a detailed overview of the enterprise. Then ER model, that is entity relationship model, which we study in the rest of the chapter, is typically used to represent the conceptual design. And stated in terms of the ER model, the conceptual schema also specifies the entities that are represented in the database, the attributes of the entities, and the relationships among the entities. Whatever the constraints, whatever the relationship, that typically the conceptual design phase that results in the creation of an ER diagram that provides a graphic representation of the schema. The designer reviews the schema to confirm that all the requirements are satisfied that do not conflict with each other. So second part is done, that is the data model. First part, gathering the requirements of the users or database users. Then next third part is fully developed conceptual schema that indicates the functional requirements of the enterprise. In a specification of the functional requirements, user describes the kinds of the operations or the transaction that will be performed on the data. Example includes modifying, updating the data, searching, retrieving the specific data, and the deleting the data. And at this stage of conceptual design, the designer can also review the schemas to ensure it meets the functional requirements. And the process of moving from an abstract data model to the implementation of the database design that proceeds in two final design phases. One is a logical design phase that maps the high-level conceptual schema onto the implementation data model of the database design that will be used. Then physical design phase, in which the physical features of the database are specified. That includes with the file organization and the choice of the index structures. Yeah, we can say that the physical schema of the database can be changed. It's relatively easy after an application has been built, because the changes made to the data to the physical schema is done by the system analyst, but however the changes to the logical design are usually harder to carry out because we are difficult to find out the changes or what are the difficulty in the logical schema rather than the physical schema, since they affect the number of the queries, because we have to run the number of the queries, updates, the scattered across the application codes. So it is very easy for in the physical design, physical schema rather than the logical schema. It is also important to carry out the database design phase with the care before building the rest of the database application. The next is the design alternative, and the major part of the database design process is deciding how to represent in the form on the design the various types of things such as the people, places, products. So we refer them as an entity. So we use them as an entity. So any place, any people, any product, any like that we use, that is an entity. So we use the term entity to refer to any such distinctly identifiable items. And in university database, example of such entities would include the instructor, student, departments, courses, and the course offerings. For example, a student takes a course offering while an instructor teaches a course offering. That are the examples of the relationship between the entities. And in designing a database schema, we must ensure we avoid the two major pitfalls. One is the redundancy, that is the duplications, and next one is the incompleteness. Just wait for 2 minutes. Now let's start with the two parts that make sure that we avoid the major two pitfalls. What are the two pitfalls or the limitation? One is the redundancy, that is the duplication. So a bad design may repeat the information. For example, if you store the course ID or course identifier, title of the course with each course offering, the title should be stored in a repeated way, that is multiple times unnecessary with each course offering. So we have to be suffice to store only those or only the course identifier with each course offering and to associate a title with the course identifier only once. So that can also occur in a relational schema also, because we are dealing with the multiple tables. So duplication is very much effective or applicable in these database designs. And the biggest problem with such redundant representation is that a copy of the piece of the information can become inconsistent if the information is updated without taking the precautions to update all the copies of the information. For example, different offerings of a course may have a same course ID but may have different titles. It would then become unclear what the correct title of the course is, because everything is repeated out. We are not judging out which is better one, which is correct one. Then next one is incompleteness. A bad design may also cause certain aspects of the expertise or enterprise difficult or impossible to model, because if the information is not correct, if the information is not complete, so it is very difficult or impossible to model the data. For example, suppose that in the case one above, we only had entities corresponding to the course offerings without having an entity corresponding to the courses. And equivalently, in terms of the relations, suppose we have a single relation that where we repeat all of the course information for the section that the course is offered. So it would be impossible to represent the information about a new course unless that course is offered. So you might try to make do with the problem design by storing null values for the section information. Such a workaround is not only uneffective but may also be prevented by the primary key constraints. And avoiding the bad design is also not enough. There may be large number of the good designs from which we have to choose. So as an example, consider a customer who buys a product. It is a sale of the product. It is a sale of this product, that is a relationship between the customer and the product. Alternatively, is the sale itself an entity that is related both to the customer and the product. And this choice, though simple, make an important difference in what respect of the enterprise can be modeled well. What are the various large number of entities and the relationship in a real world scenario? Enterprise, it is very difficult or not difficult to see or not hard to see that the database design can be a challenging problem. Indeed, we shall see that it requires a combination of both the sciences and the good taste. Now, come to the next topic, that is very important topic, ER model. ER model was developed by the EF code, that is the name of the person. And this was developed to facilitate the database design by allowing the specifications of an enterprise schema that represent the overall logical structure of the database. And this model is very useful in mapping the meanings and interaction of the real world enterprises onto a conceptual schema. Because of the usefulness, many database design tools draws on concept from the ER model. That means we are using many of the times ER model in the database design, because this is one of the great tool that represent the relationship between the two entities between two tables. And there are three basic concepts that is used in ER model. One is entity sets. That may be a teacher, that may be a student, that may be a book, that may be notebook, anything that is an entity. Then the relationship sets, what is the relationship between these entities? That may be many-to-many relationship, one-to-one relationship. What are the various attributes of that entity? For example, if I'm talking about the teacher, what is the teacher ID? What is the teacher address? So these are the various attributes which we study earlier also. And the ER model has associated grammatically representation also.